What's up, everybody? I would like to go through a few things with you about the week and then go through our lesson for the week. Um, as you know, there was no school Monday, so this week picks up Tuesday through Friday. There's a lot going on this week. We're not going to have a formal Zoom meeting as usual, but if you need me, if you need to Zoom, shoot me an email, we'll set something up. Otherwise, ask me any questions you need through email, and I'll help you as best as I can and get back to you as soon as I can. Um, for the week, the only in-person days are going to be Tuesday and Thursday. Wednesday's a virtual day this week for everyone, so just don't forget that. But let's go through the week here. Tuesday, there's an ed puzzle all about the periodic table. You should hop online, watch that, go through it, answer the questions. Again, make sure you take your time, rewatch the clips if you need to. Once you answer, it's locked in, so take your time and do your best. And then Wednesday through Friday, there is a little web quest. You're going to go through the document and click on the links and find all the information you need to find about the periodic table. It deals with atoms and elements and things on the periodic table. So just open up the document, click the links in the document, find what it's asking you to find, put your answers right there in the document. Some answers you'll have to type out. Some answers you'll have to do an image search and then paste that image in there. So just make sure you're paying attention to what it's asking you to do and then answer accordingly. Okay, that's going to be due by the end of the week, so make sure you complete that and get that turned in. Okay, oh, there's also a little mini quiz at the end of the assignment. You'll go to the link, take the quiz. For the quiz portion, I want you to keep taking it until you make at least an 80%. So by the time you've made an 80%, that's perfect. 80% or higher. Take a screenshot of your score, paste it in the document, and you'll be good to go. Again, that's due Friday, and if you have any questions, let me know. But let's go ahead and talk about the periodic table and atoms and elements. So that's what we're going to talk about this week. Okay, the periodic table is what our focus is this week, and in the next few weeks to come, it'll be an important tool that we use when we start talking about chemical equations and how elements form compounds and molecules, and how we're able to look at an equation to see if it's balanced or not balanced. And then we will take what we know about elements and balance them. But the place that we need to start here is with the periodic table, because if you don't know how to look at the periodic table and read it and know what you're talking about, those other things are going to be pretty difficult. So let's go ahead and talk about a few things here. First, this handsome beast is Dmitri Mendeleev. He is the person that created the periodic table. He started grouping elements in a way that kind of grouped like elements together, and we will see how those things are grouped here shortly. But Dmitri Mendeleev is who created the periodic table. Initially, people thought there were four elements: fire, air, water, earth. Avatar: The Last Airbender. Science has come a long way, though, since that time, back in Aristotle's day. So we now know that there are 90 naturally occurring elements, and humans have created about 28 more. So there are quite a few more than four on the periodic table. Now, in the Earth's crust, you can see, just in the Earth's crust here, we have a lot of elements here. We got oxygen, silicon, aluminum, iron, calcium, sodium, potassium, magnesium, titanium, hydrogen. You can see, though, that oxygen is the most abundant element in the Earth's crust. Same with human beings. We can see what is the most abundant element inside of a human being. We have oxygen, sodium, calcium, potassium, hydrogen, phosphorus, carbon, sulfur, nitrogen, other stuff. But oxygen is also the most abundant element in the human body. So oxygen is a pretty important element. Same with carbon. Carbon is a very important element. And we will get into that kind of stuff shortly. But I just wanted to give you an idea that elements are everywhere. They make up everything. So it is important for us to know how to navigate the periodic table, to know all the facts about the elements when we begin to look into the different things we need to know about elements. Okay. So the periodic table, what is it? It shows us all the known elements in the universe. Again, we haven't explored the entire universe. Who knows? There might be some more out there. But for now, the periodic table shows us all of the known elements in the periodic table. And it organizes them based on their chemical properties. So the periodic table organizes the elements in a particular way. A great deal of the information about an element can be gathered from its position right in the periodic table. And for example, you can predict with pretty good accuracy the physical and chemical properties of an element. You can also predict what other elements a particular element will react with chemically, all based on the little bit of information that you can gather from the periodic table. And then understanding the organization and plan of the periodic table, that's going to help you obtain basic information about each of the 118 known elements. So here it is. Here's the periodic table, and you can see things are grouped in a certain way. Hydrogen is over here on its own, and then we can see the different colors represent different families of elements, which we're going to get into in a second. But this is the periodic table. Looking at this image here, you can see everything marked in green as a non-metal. Hydrogen on the upper left is the same as all the elements over on the right. The metals are blue metalloids, which have properties of both metals and non-metals, are labeled in purple here. Okay. We can also see that the elements are categorized into periods, and periods are the horizontal rows. So elements in a period do not have similar properties to elements in other periods. That's not the point of a period. Elements within a period or other periods do not have similar properties. Now, right here, we have elements grouped into what we call families, which are the columns, the vertical columns. Elements within families do have similar properties. If you were to look here and look at all the vertical columns, every element within that vertical column or family does have similar properties. And that's all based on the kind of electrons they have, which we will get into shortly. Now, again, this periodic table shows us the different types of families or groups based on what kind of element they are. In white, we have labeled the non-metals, so hydrogen over here, then the rest of them are over here. We have the alkali metals. We have the alkaline earth metals, or just alkaline metals. We have transition metals. We have rare earth elements, which are these lanthanide, actinide series elements. We have noble gases on the far right. We have metalloids here in yellow. And we have the halogens here in red. So those are the different families of metals. Excuse me, families of elements. Some are metals, some are non-metals. Okay, how do you read a periodic table? You look at the box for each element. And this example here is carbon. At the very, very top, we have what's called the atomic number, which is just a number. Underneath it, we have a letter here, or sometimes it's 2 letters or 3 letters. That's called the symbol. We have the name of the element and the atomic mass. And when we talk about the atomic mass, it's not just a whole number like 12 or 14 or 17. It usually has a decimal point. And that might be a little confusing, but we will get to the reason for that here in just a second. But this is how you read it. On the top's the atomic number. Underneath that's the atomic symbol. Underneath that's the name of the element. Underneath that at the very bottom is the atomic mass. So carbon with a symbol C has an atomic number of 6 and a mass of 12.01. Let's look at what some of this stuff means. So the atomic number tells us a few things. Carbon, for example, if you know the number is 6, you know how many protons are in there or how many electrons. That atomic number tells us how many protons are in the nucleus of this element. It also tells us how many electrons are surrounding the nucleus of this element. So when you see the atomic number for carbon, for example, being 6, we know there are 6 protons and we know there are 6 electrons. So that's what the atomic number tells us. How many protons are in there? How many electrons are in there? All right, what is the atomic mass? So the atomic mass is the number of protons and neutrons in the nucleus of the atom. So if you know how many protons you have, you know how many neutrons you have, you add them up and get the mass. If you don't know how many neutrons, you could take the mass minus the atomic number. That'll give you how many neutrons you have. But that's what the mass is, protons plus neutrons. Now, again, this number 12.01, the number shown on the periodic table is slightly different than that, which we'll get to in just a second. But let's keep going here. What's the symbol? Well, the symbol is just an abbreviation of the element's name. For carbon, it's C. For oxygen, it's O. For hydrogen, it's H. A lot of those are pretty straightforward like that. And some of them are not so straightforward. And we'll look at some examples of that here in a second as well. But here are some common elements with their symbols, like nitrogen's N. That's a straightforward one. Let's read the straightforward ones. Chlorine, straightforward. Carbon, C, straightforward. Cobalt, CO. Some of these are not so straightforward, like sodium is Na, or potassium is K, or iron is Fe, mercury is Hg. Some of them are very straightforward, some of them are not so straightforward. Now, I'm not going to make you memorize any of this. You'll always be able to use the periodic table for class, but I do want you to notice some of these are not so straightforward. Some of them are straightforward. Here, if we were to look through this, we can see like oxygen is O, hydrogen is H, sodium is Na, potassium is K, iodine is I, carbon is C, chlorine is Cl, iron is Fe, silver is Ag. Over here on the right, here's some questions. You could push pause right now and see if you can figure them out, and we'll get back together in a second. So go ahead and push pause and try to figure those out. Okay, hopefully you were able to figure those out, but Mg is magnesium, Br is bromine, N is nitrogen, S is sulfur, Ca is calcium, B is boron, Zn is zinc, Si is silicone, Ne is neon. So those are some pretty straightforward ones. Now let's take a second here. Now we got some of those weird ones where the names do not make a whole lot of sense. How about push pause for a minute and see if you can figure some of these out? So push pause and figure them out, and we'll get back together in a second. Okay, hopefully you took a shot at figuring some of these out. I know these are weird, but let's go through them. Berkelium, BK. So if we read through this list here, that's going to be letter D, home of the university in California where the element was first made. So Berkeley University. So Berkelium is named after a place. Curium, CM. This is, let's see, Nobel Prize winner who studied radioactive elements, Marie Curie. So it's named after her. Curium is named after Marie Curie. So that would be F. Einsteinium, ES. This would be the Nobel Prize winner who studied relativity, Albert Einstein. So that would be A. Gold, AU. So that's going to be from the Latin name of gold, aurum. So that's where that comes from, letter H here. Krypton, KR. This is the Greek word for hidden or kryptos. That's G. Iron, Fe. Comes from the Latin name ferrum, so letter B here. Iodine, or I, comes from the Greek word for violet, iodes. Or titanium, that's going to be letter C, for the powerful mythological beings called the Titans. So see, these, that's not really straightforward. Some names are straightforward, some names are not. And there's a few examples of both. I just wanted you to see that so that you will understand that sometimes it might be a little harder to find them on the table, but this is why. Some of the names are straightforward, some of the names are not. Again, I'm not going to make you memorize them. I just wanted you to be aware of that. Okay, how do I find the number of protons, electrons, and neutrons in an element using the periodic table? Well, again, the number of protons, you just find the atomic number. So for carbon, there are 6 protons because the atomic number is 6. For the number of electrons, again, find that atomic number. It's going to be the same. So for carbon, there are 6 electrons. And then for neutrons, you take the mass minus the atomic number. Typically, we're going to round here to a whole number. Again, this decimal point number will make sense in a minute. But let's say 12 minus 6 gives us 6. So in the case of carbon, there are 6 neutrons. Now, it's not always the same as the atomic number, which is why we don't just say neutrons equals atomic number. We don't say that because it's not always the case. However, in carbon, it does happen to be the case that there are 6 neutrons because mass minus atomic number equals 6. Okay, now I keep talking about what's that decimal point? What is that all about when it comes to the mass? Well, let's talk about this word here. Sometimes we have different forms of the same element. Those are what we call ions. So an ion is an atom that's been electrically charged as a result of gaining or losing an electron. So you take your same element. If you lose an electron, it becomes positive. If you gain an electron, it becomes negative. And isotopes are several different forms of an element, each containing the same number of protons, but a different number of neutrons. So it's the same element, but a different form. And I thought we should take a second here. Let me go back. Let's also talk about how protons, electrons, and neutrons each have their own charge. Protons have a positive charge. Electrons have a negative charge, and neutrons are neutral. They have a neutral charge or no charge. Now, here's the way I remember it. It's kind of silly, but it works. Protons are positive. P is what starts both protons and positive. Neutrons are neutral. Well, neutral and neutrons both start with N. And then we have electrons. We just need to know that that's the one that's left, negative. So just remember, protons are positive, electrons are negative, neutrons are neutral. So when we start talking about things like ions and isotopes, you'll know what's going to happen. If you lose an electron, so you lose a negative charged part of the atom, it's going to have more positive charges left over. So that's why losing an electron makes it a cation or a positive isotope, positive ion. Or if you gain an electron, so you're gaining some of those negative charges, overall, you're going to have more of a negative charge. So you're going to be an anion, a negative ion or negative isotope. Now, most atoms have the same number of protons and same number of neutrons, but sometimes these isotopes have less neutrons than they do protons, even though it's the same element. Now, finally here, the atomic mass number with a decimal point, it has that decimal point on the periodic table because scientists have taken all of the possible isotopes, added them up, and taken an average number of the neutrons. So when you add them all up and divide them and get that average, and that's where the mass comes from. That's why the mass on the periodic table has a decimal point, because it's an average of many different isotopes. For the sake of problems you might encounter in class, we're just going to say protons plus neutrons equals atomic mass. So you won't have a decimal point answer for that unless you use the periodic table, which you should only use the periodic table if it says to. Otherwise, the mass is protons plus neutrons. Okay. Well, that is your information for this week, all about how to use the periodic table and the information within the periodic table for each element. If you have any questions, make sure you email me, ask me anything that you need help with, set up a Zoom if you needed a Zoom. Otherwise, good luck on these assignments,